Welcome. In today's video, we'll be telling you a few things you may not know about ROHM Semiconductor's isolated gate drivers. Joining us today is David Doan, Senior Technical Marketing Manager who oversees isolated gate drivers for the Americas. Let's get started. So David, tell me how this product line and business got started.
Sure. Yeah. So ROHM first started development of this isolated gate driver for silicon carbide in collaboration with Japanese OEM back more than 50 years ago. The development started in 2008. It was completed about 2 years later in 2010. And then 3 years later, we went to production. Since then, we've been continuing to working closely with customers, making continuous improvement of product line. So today, we have fairly comprehensive lineup for automotive and industrial applications. And I think by 2021, we have shipped over 100 million pieces. Today, we believe that we have the largest market share for non-optical isolated gate driver. And maybe not apparent on the web, but a significant portion of our business comes from custom design. Yeah.
So the name of the product is isolated gate driver. What does isolated even mean?
Yes, so isolation in this case means electrically isolated from one side of the chip to the other. Specifically, in one side of the chip is a low voltage, like 5-volt microcontroller that controls the system. On the other side is the high voltage side that contains the high power devices like IGBT or silicon carbide. So those are high voltage devices. So the function of the isolated gate driver is to making sure that there's communication, one side, the low side, can control the high side, and yet it is electrically isolated to protect both the device itself and any human that may come into touch with that. Yeah. So the other one is that when it comes to isolation, ROHM's isolation technology is based on inductive coupling or magnetic coupling. And with silicon dioxide as insulation material on chip. So when you look into the chip, it is really 3 die in one IC package. So there's one die that interfaces to the low side we mentioned before, and the one die that acts as an isolation barrier, and then the other die to interface to the high side of the system. So the advantage of using inductive coupling is that it has very high common mode noise transient immunity. The acronym for that is CMTI. And with that inductive coupling technology and with our additional circuit enhancement, ROHM isolated gate driver can achieve very high CMTI, and the rating is, I think, it survives up to 200 kilovolt per microsecond, meaning the output voltage, the one which controls the high side switch, is not changed by transients up to that level.
Why do we use silicon dioxide for insulation?
Oh, good question. Yes, so silicon dioxide is used because it has very high dielectric strength. In common terms, that means it can withstand very high voltage with very thin thickness. So to give an example, silicon dioxide at 1 micron thick, it can withstand up to 500 volt RMS. So today, for example, our lineup, we offer 2.5 kilovolt RMS and 3.75 kilovolt RMS. So for 2.5 at 500 volt per micron, then you need something like 7 micron. For reinforced isolation, you may need to double that. But just to give you an idea why it is used, because for very thin, very thin layer, it can withstand very high voltage. That's why it's used. And the other is also very important is that silicon dioxide is a very well understood material. They are used pretty much not just in isolated gate driver, but in CMOS processing everywhere. So it is very well understood material, is well characterized.
That's really interesting. So what does 2.5, 3.75 kilovolt mean?
Right, so these ratings are subject to regulations. So for example, according to UL 1577, in order to achieve 2.5 kilovolt RMS or 3.75 kilovolt rating, we need to test the device at those voltages for 1 minute without failure. So that's what they mean. And when related to the application, what it means, like when you use a 2.5 kilovolt isolated gate driver, you can use it with a battery voltage or a DC burst voltage or working voltage. Different people use different terms. So for 2.5, you can use those gate driver with a working voltage of 566 volt. For isolated gate driver rated for 3.75 kilovolt RMS, the working voltage can be as high as 891 volt. And if we really want to get technical to be 100% correct, then we have to say yeah, but that also depends on the pollution degree of the environment in which they work.
I've noticed these chips look a lot larger than other ICs I've seen. Is there a reason for that?
Yes, there is. And that is because the chip's capability to provide isolation depends not only on the on-chip isolation barrier that we talked about earlier, but also depends on the distance between certain pins on the package. So that means the further apart they are, the higher the voltage that they can withstand. So that's where the packaging consideration comes in. So because electrical short can happen not only inside a chip across the isolation barrier, but they can also happen outside it or around it. So that's where the pin distance between the pins and the pin positionings are important. So to give you an example, our 3.5 kilovolt RMS isolated gate driver, the package that we use for the more demanding application like automotive traction inverter, we tend to use bigger package for that, 10 by 10.4 millimeter. And with that, we can offer the technical terms, grippage and clearance. We can offer grippage and clearance of 8.3 and 8.66 millimeter respectively.
So what else is important when it comes to selecting a gate driver?
Right, yeah, there are many others, and unlike the isolation that we just talked about, to a much greater extent, the other consideration depends very much on the type of application and depends on particular use cases. But broadly, I guess we can classify them into two categories, because the main function of the isolated gate driver is, one is to control the power switch, IGBT or silicon carbide MOSFET, in a safely manner, and the other one is to drive them efficiently to minimize the loss. In the first categories of protection or safety feature, the common features are like UVLO on both the low side and or high side, the Mueller clamping or negative voltage turn off, soft turn off, two-level turn off. There's a lot of them. But I guess I can mention a few things that we believe that ROHM may offer certain differentiation. For example, we offer separate output for the fault reporting. So that means the MCU know very quickly the critical one from the non-critical one because they come out from different pins. The other one is that we have ability to measure, say, high voltage, and the temperature on the power switch side, and then we modulate them, multiplex them onto a single pin and send them across the isolation barrier to the low voltage side.
What about the second category?
Yes, so the second category is what I would call performance enhancement. For example, one is how to control the gate current that goes into the power switches. And these days it's common to offer what we call the slew rate control, meaning you can select how much current you drive into the gates of the power switch, and that directly affects the efficiency when you switch these switches on and off. So in addition to that standard feature, we offer something that I would say probably a step beyond that, what is the ability to do closed loop control, meaning not only the user sets, say, I want to drive 8 amp or 20 amp to the gate, but we can also monitor exactly how much is being driven, and then we can adjust it dynamically so that the gate current is precisely what the user needs. And the benefit of doing that is that it will reduce the switching loss by, obviously depends on the application and condition, but I would say anywhere from 5 to 10%.
Thank you, David, for all your insight today. There's actually so much more that we want to know about ROHM's isolated gate drivers. However, we can continue that in our next video. So stay tuned. See you next time.